So I've got like a couple of seconds, see if I timed that right. Yes, okay, just ticked over to 11:05, so I can just like instantly start as the recording starts. Before I kick off the lecture today, I just wanted to show you, where do I have it? Over here. This section of the course website that just went up the other day. These are help sessions. So for the moment, we have help sessions on Tuesdays and Fridays. So Tuesdays in the evening and Fridays in the middle of the day. There will be other ones on other days of the week that will open up as we start giving you more assignments and things. The help sessions are times for you to be able to get one-on-one time with tutors. So if you're worried about something or you don't fully understand something, it's pretty easy. I mean, if you can make the timing, it's pretty easy to be able to turn up to one of these and say, hi, I'm from COMP1511 and I have a question about this or that, and then a tutor will be able to talk to you about it personally. Question there? Yeah. The question was, if a group of you have the same kind of question, and this will happen if I haven't taught something properly, this will happen sometimes, right? Yeah, you can go in as a group and say, look, the whole lot of us were confused about this. We talked about it amongst ourselves. We couldn't get a good kind of real grasp on something. Can you show it to us? The tutors actually love that, because that way they can answer like half a dozen people's questions all at once, and that's actually quite efficient, so they like it. So yeah, feel free to come along to the help sessions. We've got a couple of your actual tutors. Some of these might be your actual tutors who are going to be there and able to answer questions. The best time to sort of get solid on the techniques and stuff that I'm teaching you is basically as soon as you can, right? Because the longer that you wait, the more likely it is you're going to forget the things that I've said and then have to relearn everything from scratch. What we don't want is everyone getting into the assignment, and then when you're in the assignment, you realize everything that you've forgotten. So just try to keep track of things as you go along. Okay, can I get everyone quiet now, please? I'm going to get started on the meat of the lecture today. So before I get too deep into it, I'm going to do my usual, which is a bit of a recap on everything else. So, question I'm going to ask at the start of every lecture and just sort of answer it so that people can get a good grasp on everything is, what did we learn yesterday? So, what were we thinking about yesterday is we did a bit of a recap of everything that I'd taught. So I looked at all of the techniques that we've got so far. We're talking about variables. We're talking about relational operators, if statements. We're talking about printing and scanning. Is there anything else I've forgotten? Logical operators to ask multiple questions. And we looked a little deeper at some of those about how to use things like hash-defined constants. So I did an example with the dice size that shows how hash-defined constants can make our development easier. They can also make our code easier to read. We also had, I think, our first look at modulus working. So these are some of the little details on the side. Like, you're not always going to be using these things, but I don't need to teach you that much about how to use like plus and minus and divide and multiply and stuff, because I think people will probably be able to work that kind of stuff out on their own. But I thought I'd show you some of the stranger things. Yeah. So today we're going to start a new kind of technical technique. I don't know, there's a nice way to say that. Oh well. Known as looping. So anyone who's done a bit of programming before has probably seen this kind of thing before. But if we look at what we were talking about yesterday. So yesterday we were talking about the user typing in input from the dice and that input potentially being wrong. So someone actually came up to me and asked me, can we actually build up some code? I can't remember who it was. Can we build up some code that can ask the user to just type in the number again if they got it wrong? So I can tell them you got it wrong, but can you please type it in again? And they realized that this kind of wasn't working, because they'd be like, ask them to type it again, ask them to type it again, ask them to type it again. And then there was a limit for the number of times they could do that, right? Because they were just sort of copy pasting the same, can you type more stuff in code. What we're going to cover today is the ability to have code that runs more than once. So we can put code inside a set of curly brackets, and it will go again and again and again until we set up certain conditions with which that code will then stop running. The cool thing about this is now if we want to do multiple things, it's really easy for us to do multiple things without having to write multiple pieces of code. Because it would be really, really cumbersome if I said, read in 10 dice. And you were like, well, why are you rolling 10 dice for starters? Like, what kind of game is this? But it's probably Warhammer. If we needed to do that multiple times and it was exactly the same code, we don't want to just copy-paste the same code multiple times. What we want is a more intelligent way of doing things. So today we're going to look at a particular construct of loops called while loops. We're actually only going to look at one type of loop for this whole course. So a lot of people will have seen other kinds of loops. We're going to use one which is very, very generic and is able to be used for kind of all kinds of looping situations. So it's sort of the only one you need, but as you learn more about things, you can use other different things if you want. Okay, so, I've already sort of talked about this. One of the things I was saying before about the way C works, right, is inside our main, every line is just going to be read from top to bottom, and then based on what's on each line, my computer's going to do something. We've seen with the if statements that we're able to turn on or off parts of code, so we could say execute what's inside the if, or don't execute what's inside the if, execute what's inside the else, or don't execute what's in the if and just skip over it and do something else. So we have the ability to choose what code we're going to run, but still we're in this way of kind of going line by line. We're just going top down and we're continuing downwards. One thing that we might want to do is to be able to repeat code. So like as I was saying before, a good example of that is instead of what we did yesterday where we were just going to automatically correct the code and we say, all right, you typed in something wrong, here, I've just fixed it for you, and we went through all these cool ideas, right? Like how to do it with modulus, clamping, or we could just reject it entirely. Instead of rejecting it entirely, we could sort of reject it temporarily if we wanted to. We could say, stop there, that was incorrect, please try again, and then ask the user to type in another number. We could totally do that. If I'd gone with what I taught you yesterday to do that, we would have had to copy-paste the scan in stuff code multiple times to go, okay, I'll give you 5 tries to get this right. And then if you don't get it right by the 5th try, we're just going to kind of end the program or something like that. Whereas if we have code that can loop, we could potentially have this thing run an infinite number of times so that eventually the user is going to type in the right number or a number that will work. We could also set up that program to run intentionally multiple times because, say, they're making multiple dice rolls in a row and they don't want to stop the program. You could just conclude a dice roll and then go back to the start of the program and go, okay, now we're going to run it again. So looping has all these capabilities for us to be able to, if we can repeat code, we can do a lot of really useful things. I realize that looping, I should have just kept the same example going. We're going to start a new example today, but that's all right. It's other looping things. So this is what a loop looks like in code. While loop is a very, very simple sort of coding construct, and you'll notice that it looks exactly the same as an if statement. The only difference is the keyword. So the if statement was if, and there's an expression which was our question, and then we had some curly brackets, and inside the curly brackets, stuff was going to happen. The while loop functions nearly identically to the if statement with one difference. So it will check the expression. Same way that if statement checks the expression, then it'll say, okay, if that's true, I'm going to run what's inside the curly brackets. If it's false, I am not going to run what's inside the curly brackets. So just like an if statement. But the only other trick is that if it did run what was inside the curly brackets, when it gets to the one at the bottom there that closes it, it jumps back up to the top again. So basically what it does is it runs what's in here. When it hits this curly brackets, it goes right back up to the while, and it runs that line again. So what it's going to do, when it's finished running what's inside the curly brackets, it goes back up to the top. It checks the expression again to see if it's true. If it's true, it runs what's inside the curly brackets again, and then it jumps back up. And it'll keep doing that while the expression there is true. See, that's why it's called a while loop. So while this question is true, we will run what's in here, and we will keep doing it while it's true. So when we get down to this idea, we are now capable of making code that sort of runs forever. So one of the most interesting things that we have to think about when we're going to do repeating code is how to make it stop. So it's nearly more important. Oh, oops, I jumped a bit. Oh no, I spoke about that already. Yes. All right, I'm going to skip that slide because I already said all that stuff. Don't worry, you can download my slides later and look in the details if you want to. There's two ways that we can make a while loop stop. I'm going to talk a little bit about these here on this slide, but then we're going to go into details about what they are. So one way is we can use something that we would call a loop counter, which is an integer variable. And the integer variable can count how many times we have gone through the loop. So we can make an integer and say, this is how many times we've gone through the loop. And then our expression, our question in the loop can be stop when you've gone a certain number of times. So we can say keep going until you've done a certain number of times to the loop and then stop. So that could be, for example, if I said roll 10 dice, that thing could be count up until we've gone 10 times. Once we've gone 10 times, stop the loop. The other way we can stop the loop is just set up a condition. So one of these ways is we call a Sentinel Variable, where we have another variable that just says if this at any point becomes something else. So we could do this with a variable that we say, okay, this is 1, and while it's still 1, keep running the loop, and if we flick it to 0, stop running the loop. I'll show you examples of this. So I just wanted to show you this kind of theory. So these are the two main sort of ways that we're going to use while loops. So I'm going to show you the easy ways to just set up both of these. And then we'll have the capability to run loops in a reasonably safe fashion. So the first one is a loop with a counter. So we have an integer there, a counter, and we like to start these counters at 0, because if I start the counter at 0, the counter tells me really specifically how many times the loop has run. So what I do is I have counter here, and I'm doing counter less than 10, and this is me saying I want to run the loop exactly 10 times. So every time the counter is less than 10, the loop runs. But each time the loop runs, the loop changes the counter variable. So I'm saying counter equals counter plus 1, which means every time I finish the loop, the counter goes up 1, which means the counter is always tracking exactly how many times we've run the loop. So the first time I finish the loop, I get to the bottom. Counter started at 0, ended up as 1. Then I know that the loop has run once. And then I run it again because the counter is still less than 10, and it goes through, and each time it goes through, the counter gets higher until the counter equals 10. When the counter equals 10, then I know that the loop has run exactly 10 times, and it will get to this condition here and say, the counter is no longer less than 10, I'm leaving this loop now, and I will jump out to after the curly brackets, and I'll continue running the rest of my code. So this is good when we have a specific idea of how many times we want to run something. So we say, as I was saying, like, I want to roll 10 dice exactly, no more, no less. I can set up a loop like this that runs exactly 10 times. So that kind of thing works pretty well. This is going to be probably the most common type of loop that we're going to run in this course. We're not that often going to be running a loop that goes forever. We're occasionally, actually quite a fair bit, going to be running loops where we don't know how many times they're going to run. And so we're going to run them up to a certain point and then stop. But a lot of the loops we're going to do is going to be process an exact number of things. And so this is the way that we process an exact number of things. We set up our counter to 0. And then so long as the counter is less than the exact number of times we want to do it, and we have a +1, this will run exactly that number of times, and it will record exactly how many times it was doing things. One thing, I don't know, do people still rickroll each other? Yeah, there's a couple of grins in the audience. Yeah, you got done. Consider this while loop, and look at the expression in the while loop. The expression says 1 is less than 2. The problem I have with this expression is that it can never be false. And if it can never be false, this loop can never finish. And if it can't finish, then the rest of your program will never run, your program will never end. So actually one of the most important things we need to do every time we create a loop, and this is something you'll always remember, is every time we create a loop, we have to figure out how it's going to stop. It's nearly more important than like what we want to do with the loop. We need to figure out, okay, how is our loop going to stop? And then if we know how our loop is going to stop, then we can figure out what we actually wanted to do with it. Because if we don't know how it's going to stop, we can just make it so that our program never ever finishes. Actually, no, I was gonna pop into some code and show you some things, but I'll show you in a second. I'm gonna talk about the Sentinel variable as well, and this has got more complex code. So I think after I've shown you this one, we'll jump into VLab and I'll show you some of this looping stuff running. Okay, so this is, like, there's a lot of code in here, but not a lot of it is actually super important. But what I have is I've got an integer there, and I'm using this integer variable not as a number as such, but more as just a marker of whether something has happened or not. So I've called it end loop, and I've set it to 0. So I've kind of made it so that end loop at the moment is not active, making it 0. So I can say while end loop is equal to 0, I'm going to keep running. And every time I run, I'm going to ask my user something. So here is that kind of printf scanf stuff that we were doing over the last week. And I've got some mods here that's just saying if the input number mods with 2 to equal 0, so if it's divisible by 2, the number is even. And if the number is even, then it just prints out the number is even. If the number was odd, it prints out the number is odd and it sets end loop to 1. So what it's actually going to do is it's going to keep running every time I type in even numbers, but the first time I type in an odd number, it's going to say end loop changes to 1, and then it will loop back up to here, and end loop won't be equal to 0 anymore. And at the point where end loop is no longer equal to 0, the loop will finish. So let's hop over to some code. Oops, that's not code, that's just the forum. I forgot that I hadn't logged into this yet. I may be able to just show you this stuff because I think I saved it. Oops. Once is enough. Okay, I'm going to ls to have a look at what I've got here. CD into my COMP1511 directory. And yes, I've set up lecture 4. So I'm going to CD into lecture 4. Have a look. Oh, I do have a loop demo, so let's... If I remember correctly, this loop demo file should be the one that's in the lectures, because usually if I've put it here, then I've uploaded it to the lecture section on WebCMS, so you can have a look at it there. Okay. Oops. So I've got a few examples of loops in here. I've put some asterisks there so you can see the difference between them. So here's our basic loop. What I'm going to do is I'm just going to comment out parts of this until we've looked at it. So I'm just going to do a blanket comment out the whole rest of this program until I've had a chance to show you. All right, there's the return. So this first one here is the counter loop. So I've set up an integer with a counter equals 0, and it's going to loop 10 times. Every time we're in this loop, at the start of a loop, we know that the loop has run exactly counter number of times. I could actually put a comment here as well saying loop has run 10 times, because I know that once I finish that and exit the curly brackets, because counter was less than 10, I know that the loop has run 10 times, and also that counter equals 10 at that point. So I do know, I'm going to put a double equals there. So I could leave some more information for myself there. So if I was to run this, I've put a print statement inside the while loop. This print statement should run 10 times, and each time this print statement runs, it should tell us how many times this loop has run previously. So I'm going to Control S to save that, and we'll compile that. So DCC loopdemo.c, that's the C file that I was just editing, and the output file, I'm just going to call it loop. All right, and to run that, /loop. So the first loop there has completed a certain number of times. So the first time it runs, it hasn't completed yet at all, so it's completed 0 times. And up to the last time it runs, it says it has completed 9 times, because after it completes the 10th time, it won't report anything else to us because we don't enter the loop again. So our values of the counter as we went through, 0 the first time, through to 9th the final time. And then after we've done that the final time, it goes up to 10. And after we exit the while loop, then it says, OK, you finished this thing 10 times. So this is the kind of code where we can control exactly how many times this thing runs. If I want to run this a different number of times, let's go for something massive like 30. I can compile this again and run it. There you go. It's counting up 0 up to 29. So this kind of construct is something we can use a lot to change the number of times we want to run something. I'm going to, I'll show you this one. This is a fun one to look at. So what I might do is I might actually print this stuff out. This is what you came to UNSW for, right? Okay. So the first loop is going to run its 10 times. And then the second loop, if we look closely at what's in the second loop, this is a key element here that I have done where I have made a condition, a question in the while loop that can never be false. Well, unless there's some kind of quantum something between 1 and 2 or something. I don't have enough maths to know whether 1 less than 2 could ever be false, but I consider it a fundamental thing for the maths that I know. So if this while loop is never going to get a false answer to its little question that it asks there, then it's probably going to run a lot. So let's just compile this. I'm just going to use my up arrow to find my compile command. And now I'm going to run this, and let's see what happens. Oh, there we go. Don't worry, I will never give you up. I'm going to turn around, and then I'm going to go out the door. Anyway, okay. So we're about to be learning a lot of stuff about loops. So this is going to happen. So occasionally your program is either just going to spit out the same stuff over and over and over again, or it's just going to pause, and you're going to be like, what's happening here? Why didn't my program finish? Why didn't it go on to the next bit? Usually that means you're in a while loop that's going forever. Question there. The question was, won't this eventually crash? At the moment, no, it won't. Because all it's doing is a very small amount of code over and over again. Somewhere in CSE, there's a bank of CPUs that run VLab, but the bank of CPUs that run VLab is pretty big because all of you can log in at once. I'm still only using one of them at the moment, but it's busy. It's doing a lot of work right now, but not enough that it's going to say there's a problem. I'm still not, you could run something like, I don't know, run PUBG for like 5 hours. I'm sure someone in here has done that, right? And that's going to take way more CPU than this. This is actually just a simple little piece of code that's just going to go over and over again. So let me show you something that is going to become very important for you in your learning about loops, because everyone, while we're learning about loops, eventually makes a loop that doesn't end. When you're in your terminal here, press Control-C. Control-C will stop whatever's happening in your program. This doesn't even have to be if your program's stuck in an infinite loop like this. Anytime you want to, you can press Control-C and it will just stop your program. We've added some stuff in. This is stuff that we get from DCC. So DCC, as I was talking about compilers, like DCC is a program that translates our code into a program that our computer can run, that a machine-readable program in a sense. DCC adds in some other stuff for you. So it's basically a compiler that we wrote so that students get more information as you're learning about code. This will tell you where you were when you pressed Control-C. So you already knew where I was because you had to look at my code and it's like, oh, I know which loop's going to go forever. But if you have multiple different loops or you have multiple different control paths through your code and all these kinds of things, Control-C is really nice because it stops and it tells you this is exactly where I was. I was in loopdemo.c in the main at line 30. So line 30 here, never gonna let you down. And it didn't let us down until we Control-C'd it. So the nice thing about that is it's going to be able to tell you this is where you were in the loop and this is what was happening. This thing can also often give you more information. So sometimes if there's a variable in there that you haven't changed properly or something, and that's the reason why it's going forever, it should be able to tell you what values your variables have and stuff like that as well. So this Control-C thing is really, really handy for when you need to make a quick exit out of a loop or out of a program that's not running the way that you need it to. Especially while we're learning about looping, you're definitely going to see a lot of that. Okay, I'm going to comment this one out again because it's not going to, well, it's not going to let us down, but I'm going to keep saying that. It's not going to help us learn anything more about looping because we've seen now what an infinite loop is. That's a really obvious example of an infinite loop. You can do it yourself in much less obvious ways by accident. So there's a lot of times where we can be changing numbers inside a loop. So for example, if I have this thing here with counter +1, and let's say inside this loop I had like 30, 40 other lines of code doing all this other stuff, and somewhere up here I had something like this. I may be increasing the counter each time, but somewhere earlier on in that loop I was resetting the counter to a low value each time. Like, we can make mistakes like this. Is pretty common kind of thing to forget what we were using the different variables for. And if I do this, this loop also is going to end up going forever. I'll get rid of that now. Okay, I'll show you the other one. There. Okay. So that one at the top will still run. That's okay. That one doesn't go forever, so I'm okay to let that one run. This other one here is a loop that can go forever because it doesn't have a specific stopping case that's going to happen after a number of times. So this one here, counter less than 10, was going to just keep running until the variable hit 10, except every time it ran, the variable was going to get higher. So this is like, it's nice and precise. It's exact. It's going to run 10 times. This one here does not have that kind of precision. It's slightly more chaotic in a sense in that it just has a condition under which the loop will end. So you don't even need to worry about most of this stuff. All you need to think about is at some point we have a way of changing that thing to 1, and if we change it to 1, it's going to end this loop. So describing this code here, I'm just going to keep taking input numbers from my user, and when the input number does not match this, input number mod 2 is equal to 0. So this is me saying if I divide it by 2, it equals 0. So if it's an even number, I'm going to go in there. Otherwise, I'm going to say it's odd, and I'm going to flip end loop over to 1. And flipping it over to 1 means this expression, this question in the while loop fails, and then we'll jump out of the while loop. So let's have a look at that running. So I'm going to just compile that. I'm just using my up arrow to get my previous commands, and then run that again. So the first thing is we have the loop that had run previously, because I didn't comment that out. I let that one run. I'm not going to let the rickroll go again, though, because we need to actually get to the next loop. And now I have type in a number. So I type in a number. I get a 4. 4 was even, and it says, OK, type in another number. So it's gone through the loop, and it's repeating it. So like we were talking about a little bit based on yesterday's code, if I wanted someone to just keep typing in numbers until they got a valid number, this kind of construct would work perfectly for that. It would be saying, just keep looping until their number is in the range 1 to 20 or 1 to 6, whatever kind of dice we were using yesterday. So this is number is even, type in another number, number is even. Let's type in an odd number. Number is odd, we exit the loop. So we're not going again. So this doesn't have a fixed number of times it can run. It can run until we find a different condition. So for example, if I was trying to, say, process a certain number of students who are in this course, I know exactly the number of students in this. Well, I can't remember it exactly. It was 740 something. I don't know. Enrollments go up and down, so I don't have the exact number. But if I did, I could say loop through exactly everyone in the course. But if I wanted to say loop through all the students who are in this room, I don't know exactly the number. Like I could pick roughly, because there's like 500 seats here and we're nearly full, so we're probably like 400, 450 people. But I don't know, so I could just say, keep going until we run out of people, and then this loop could keep going, and then it would flick a condition where it says, okay, I've looked at everyone in the room, now I will stop this loop. So 2 different kinds of loops, one that runs a fixed number of times, and one that runs until something changes. And so these bits of code are going to be pretty useful. This one here, and this one here. So they're in the demo that's on the lecture slides. They're also on the slides themselves. These 2 are the ones we're going to use most of the time. There's also this one. This one's an educational example. This is one that I don't expect you to use most of the time because it goes forever and never stops. OK, so let me go back to here. I'll figure out which slides I've skipped over by accident. Oh, no, I haven't. There you go. There's another meme. Oh, good. All right. We can put a loop inside a loop. So things get more interesting if we put one loop inside another loop. Because what we get is, and this is something that we come to this realization, I think I mentioned this last week possibly, that we could put an if statement inside an if statement. I think I have a slide on that, do I? No. Oh, wait, no, that's the break time. OK, I'm going to talk about that later. OK, let's talk about loops within loops first, because I've got that in the demo as well. So everything that's inside the loop will run every time the loop runs. So if I look at this here, that printf there that ran 10 times, I wrote that printf once, and then it ran 10 times. If that printf was another loop, then that loop would start and finish 10 times. So if I want to, I can get to this kind of ability to sort of multiply my loops. So I can say, I want to run 10 times a loop that also runs 10 times, and then that loop inside will end up running 100 times. And that can happen when I want to do all kinds of potential interesting things. We can use it to calculate things with statistics, which we're going to do later today. We can use it to draw things, and I'm going to do that right now, actually, in this demo here. An example of how we loop within a loop. So this is a loop within a loop. So we have 2 variables here. There's a y that is outside both loops, and there's an x which is inside one of the loops. What I've actually done here is I've done 2 of those loop by 10 things. So I had the one before that was counter less than 10. I started at 0, and then I went up to 10. So if I have, oh wait, I can't highlight on that, it's a slide. I have the y is equal to 0, y is less than 10, and at the bottom of its loop, y is equal to y plus 1. So that's exactly the same structure to make something loop 10 times. But the code that's inside it is interesting because this is x is equal to 0, x is less than 10, and x is equal to x plus 1. There's some actual other code there that's printing stuff out, but the structure of what I'm doing is I've just literally taken that 10 loop thing and I've put a 10 loop inside it, which means that the loop inside is going to run 100 times total, but it's going to run 10 times every time the outer loop runs. So we can do some cool stuff with this. So let me hop across to the code and I'll show you that. I might just, I'm going to comment out the rest of the program for the moment. So I'm using the * comments, which allow me to just comment out large sections of things. This is not me trying to tell something to another programmer or to myself. That's just me saying, computer, please don't read the rest of the code here because I'm just working in a particular part of it. You'll notice that if you look at the code that I put on the lecture section of the course website yesterday, I just did things like that where I just comment out some parts of it. So you can turn on or off different parts of the code as you want to test out what I've been showing you. So what I might do is I'm going to write this from scratch. I think it's easier if I start from nothing. So I'm just going to delete all this from now. And I'm going to start with drawing a row of stars. So my end goal for this is I'm going to draw a grid of stars, just asterisks. So what I'm going to start with is drawing a row. So I'm going to have an x equal to 0. And while x is less than 10, I might just put some white space down here so that's in the middle of the projector. It might be easier to see. Okay, so while x is less than 10, x is equal to x plus 1. I just want to make sure that in the same way that I like to close all my brackets before I write anything in them, although I think I didn't exactly do it a while there, I like to make sure that if I was to just leave this code here now, it wouldn't run forever. So I've made sure that my while loop has a way to stop before I even start working on it, before I start going deep into it. I know that it's going to run and stop. So I've got my while loop safe first, and now I'm going to add stuff to it. So this structure here is what I was showing you a second ago. We're going to run this exactly 10 times because x is going to start at 0. X is less than 10. X goes up by 1 each time. If we were to print out the numbers, we would get 0 through to 9 again, like we did with that previous loop. This time, instead of that, what I want to do is I want to print out some stars. So I'm going to printf star like that. So because I haven't put any spaces in there and I haven't put any new line characters or anything, I'm expecting these to all just appear next to each other on a line. So let's try this and see what happens. Control S to save, find my DCC command, and then run it. Cool. All right. I didn't put a new line on the end, so it's a little bit messy, like my prompt is directly after the stars. But still, it's doing what I wanted in terms of printing off a row of 10. Yeah, 10. Just had to count them quickly. 10 stars. So if I want to make a grid of these, I could, if I want to, do this. This isn't even exactly going to work. I lost count. I don't know. I could do something like, this isn't even going to work, by the way, because I'm redeclaring an integer that I've done before. Also, this is not the way that we want to code. This is a way of coding that I would consider to be fraught with danger, because if I wanted to change the number of things in a row, then I would have to go through and like find them all and change them and stuff, and it's just really messy. Also, who wants code that looks like this, that just has the same thing over and over and over again, right? It doesn't help us at all. So if I want to run the same code multiple times, I should put that in a loop. So I need to go through and just remove everything that I've added there. All right. So if I have this code and I say, okay, I want this thing to loop multiple times, so I want this code here to run multiple times, I can make another loop. So this is why I had my y here. You can see because the x and y, so the x coordinates are going across and the y coordinates are going to be going up and down. So if I have a y and I'm going to build a while loop, I'm just going to build this separately for the moment. So it's a while loop that goes until y is 10, and it has y is equal to y plus 1. I think you may have noticed by now the way I write the code, so it depends on how much of my code you've been looking at and things. Note that every time I use curly brackets, I push everything forward. In gedit, a tab is going to be 4 spaces. 4 spaces is a general convention for how we do these things. Different companies will do it in different ways. Some people will do a 2-space tab. Some people, I don't think many people are still doing it, but some people used to do an 8-space tab. But we do a 4 because it's reasonably easy to see what's going on. And the way that works is for readability, so that we can always see what we had intended to be inside the loop and what we intended to be outside the loop. So once we're outside the loop, it goes back to where it was tabbed before, where the bracket is. The thing is, though, we want this code to be inside this loop, so this code can run 10 times. So what I'm going to do is I'm going to grab this with a Control X, which is a cut. What that's going to do is just grab all the text so that I can paste it. So I'm going to go in here and press Control V, and that pastes the code in there. For the moment, this looks a little bit messy because I can't see exactly what's inside and outside the loop. So what I'm going to do is I'm going to tab this in, and that, and this to be inside this loop should also be indented, and this should be also, this bracket closes that one, so it should be vertically aligned with the line that opened it. This one is inside this one, so it's at the right level of indentation, and that closes the lot. So what I should be getting now is my line of 10 stars should run 10 times. So I should be getting 10 lines of 10 stars. There's a trick in this. Let's see if anyone picks up on the trick. Yeah, there's a few people. No, wait for it. I just want to run it first. And I'm pretty sure you know what's going on. But I'm just going to run this, and I'm going to get my perfect grid of stars, right? He knows I'm not going to get it. Yeah, so it's a trick question. Okay, so I'm going to compile this again. And let's see. I can tell people have seen that something might go wrong here. So I'm going to run this loop. I did technically get my 10 rows of 10 stars. It just happens that they're all next to each other, and I haven't split up these rows. So let's go back to the code and see how I might do that. So each row prints out 10 of these. We know that because it's in a 10 while loop that prints out 10 of those. But at the end of each line, we probably want to go down to the next line so we can make our nice grid. So I might add in another printf here. And this printf is only going to do one thing. It's just going to end line. So I'm going to put a little end line there. So I should get line of 10 stars, the enter key gets pressed, and then another line of 10 stars, enter key gets pressed right down to the bottom. So I should be getting 10 separate rows. Was that what you were looking at? Oh no, something else, yep.
Is it okay that the int statement is inside the while loop and we'll keep defining a caps?
Ah, okay, that's an interesting question. So the question was, is it okay that the int x that we've got here is inside the while loop? And this is where we start to get to, I love when people ask questions like that, and I have a slide prepared for it, because I do. So, what do the curly brackets do? So I have a phrase here that I've co-opted from another famous phrase. What goes on inside the curly brackets stays inside the curly brackets. So it's Mark's Vegas rule of programming scope. So the way the curly brackets work is they set up a region of code. They say that everything inside this area is one block of code. The magical thing that the curly brackets do is that when they finish, everything that was inside it disappears. So it is literally whatever goes on inside the curly braces stays inside the curly braces. No one talks about what happened in Vegas. I should have changed the text on that. Anyway, so when we have the int x, and I'll go back to the code, the int x that is created inside these curly brackets, so it highlights the top and the bottom one, that int x will cease to be a variable once we reach this. So every time we finish that loop, the int x actually disappears. So when we declare the int x, we talk to our computer and we say, give us a piece of memory, 32 bits of memory, we're going to write a value into that. We're going to write a variable into that. And so we put a 0 in there, and then we're changing it multiple times until it reaches 10. Oh, sorry. Yes, yeah, we are changing it multiple times until it reaches 10. But then when we get to this curly brackets here, so this is the curly brackets that actually contain the x. So it's not this curly brackets. This curly brackets only contains this code in here. But the actual variable that we created there will disappear when it hits this bracket. So once we finish the loop, the x disappears, and then we would start another run of this outer loop, the while loop. And then the first thing the while loop does is it says, make a variable called x. My computer will give me a piece of memory, and I can start writing values into it. It won't even be, it's unlikely to be the same place in memory that we had the previous x. It's like a whole new variable. So what we get is this idea that the curly brackets actually determine a piece of code that is nearly individual to itself. Like it won't necessarily share stuff with other things. We're going to go deeper on that concept when we start using these things to actually separate pieces of code from each other. But for the moment, we can just think of it as anything that we create that is inside a set of curly brackets is not going to last longer than the curly brackets. So, for example, I can try to do this. So if I look at my code top down, I can say there's an int there called x. So I should be able to print out the value of that integer x. Let's compile this and run this and see what happens. I'm actually not sure where the problem will be. It might notice at compilation that x doesn't exist, or it might not notice until I run it that x doesn't exist. So let's find out. So I'm going to go to my compile command. I think that's my compile command. Yeah, there it is. Oh, error. Use of undeclared identifier x at line 69, character 39. So line 69 is here. Character 39 is probably going to be about there. Yes, it is. So it's telling me, and if we go back to the error message, undeclared identifier. So if you remember from, was it the first lecture? First or second? No, second lecture. where I talked about declaring variables. Declaring a variable is me saying to my computer, I want to store some information, give me some memory for some information. It is saying that x has never been declared, which is interesting because if I look a few lines up, I think x has been declared. Except because it was declared inside the curly braces, so the curly braces here to here, it went away once those curly braces closed. So all idea of what x was, the computer has completely forgotten what x was, so x doesn't happen here. X was only for use inside this section here, and anything outside of that section, it ceases to exist. So that's a very long answer to your question, but hopefully that gives you some information, right? Did you have... Yeah.
One more thing, would you recommend then to do all your int statements at the beginning of your program so you can use them throughout and have them?
Okay, that's a good question, right? So the question was, would I recommend declaring integers all at the beginning of the program? So if I wanted to, I could come back up to the top here and go, int x equals 0, int y equals 0, int counter equals 0, and things like that. So that way, they exist through the entire program. Let's do that, and we'll see what happens. That's always my favorite way. Okay, I'm going to get rid of this one because I know that this one's trying to access something that doesn't exist. Oh, actually, it will be able to access it now if I do this. Okay, so if I have my x and my y outside of my loops, then I know that I'm going to be able to use them outside the loops. I love that you segued me into what I was going to talk about next. It's like, oh, this is so good. Okay, so the x and the y is outside the loops, which means I can use them through all the multiple loops. X is still accessible in all the loops that I want it to be accessible in. Let's compile this and run this. So where's my compilation command? There. And I'll run it. Very twisty. Someone else has seen the Pokemon movie. So, does anyone have an idea what has happened here? We've got a question down the front, yes?
Your value of x has stayed constant.
Yes.
Evaluate x, I guess, just before the value.
Yeah. So, for everyone else, the value of x has remained. So I'm just paraphrasing what you're saying. The value of x has remained because when it was inside here, every time we restarted the loop, we restarted x as 0. Now we're no longer restarting x at 0. X started at 0 once, and then we added stuff to it until it was 10. And then the next time we came around, it was already 10. And since it was already 10, we never drew any stars after the 10th star. Because we recorded x as 0, we added every time we drew a star until it was 10, and after it was 10, it could never draw any more stars. Question there, yeah?
What happens if you put the int x equals 0 inside the curly braces as well?
What happens if we put the int x equals 0 inside the curly braces as well? You're onto the solution. There is one tiny issue, but you are onto the solution. So, let's declare a new x inside the curly braces and see what happens. So I'm going to compile this. Did I save that? Not sure. Just press Control S just in case. Uh-oh. There's a warning here. The warning says, declaration shadows a local variable. That's a very ominous way of saying that. I'm shadowing him. We have accidentally declared a variable twice. So remember, when I say int x, I say to my computer, hey, can you give me a piece of memory? And I will call it x. And when I go to make changes to x or read things from x, I will go to that piece of memory. If I do int x again, I say to my computer, give me another piece of memory. And I'll call this one x. And it goes, nah, that one's called x. You've got two of them now called x. Things are a bit weird. However, let me make a small edit to your suggestion, and this will work. If I say there's only one x, and I don't want to make a new x inside the curly brackets, but I'm going to use the x that I'd already created. I'm going to use it again and again and again. But before I start drawing anything, I reset it to 0. If I reset it to 0, then it should be able to draw stars again on the lines that follow on from the first line. So the problem of here, of the lines not drawing more stars, was a problem because the x went up to 10 and never went back to 0. So this loop never ran again once x was 10. But if we reset it to 0, it should run again. So let's save, compile, and run this. We're back to the kind of thing that we wanted. But we have a double bonus here because the x actually survives long enough for us to be able to print it out later because the x was declared outside of curly brackets. There's a pro and con to this, right? Because the x didn't actually need to survive longer than the while loop. So the reason why I put it inside the while loop to begin with was I only needed that x to track that line of stars, and then it could disappear. So it is a choice, and this is one of the things that we're going to, this is the kind of thing I was trying to teach you a bit about yesterday, is there's so many different ways we can achieve the same result with something like C. So I just, subtle, the differences we made here, but in terms of what the user sees and stuff, it's going to look exactly the same. So there will be a lot of different ways of doing things, and we know this, because we'll see your first assignments, and they'll be like, how did these two people learn from the same class? Like, what the hell? It's like completely different. But that's totally okay, because each of us is going to find our own ways, I guess, to speak the same language. Like, if we were to all kind of explain the same concept in English to someone, we would all probably end up explaining it in different ways, you know? And so it's okay if your C code looks very different from someone else's, but it's also got good style and stuff, you know, it's got proper indentation and good variable names and things. C code can look quite different between different people and still achieve the same result. Okay, what was I doing? Drawing a grid of stars? Yes, we've done that. Curly brackets. Okay, so about to take a break. I just want to reiterate this interesting thing. We just put a while loop inside a while loop. A while loop is just a piece of code. An if statement's just a piece of code. So we can put while loops inside while loops. We can put while loops inside while loops, inside if statements, inside while loops, inside if statements, etc., etc., etc. C will be fine with it. C will just run it. But the problem is us. The problem is how confusing is it for you to actually remember what the hell's going on, and also for you to modify it later so that you understand it. So look out for how deep you put things inside each other, because that can cause problems. All right, let's take a break. Come back in 5 minutes, and we'll put together a program using this stuff. Hey, how's it going? Yeah, no, totally.
I keep getting this error, and I'm not sure why. It's here.
Okay. Line 5.
5.
Expected identifier, open brackets. Ooh, one thing that we've got missing here, I'm just going to go across to my code, is remember that for every program, it has to have this int main void and the open curly brackets. So it won't know to run any of that stuff unless it's had the curly brackets opened and said, okay, now we're going to start running code.
Okay.
So every C program needs this main. If it doesn't have a main, it doesn't know where to start. So I think that's what you're going to need there. Okay. And that should be fine then. I mean, there might be other stuff to look through, but that'll at least get you started. Okay. Yeah. Cool. No worries. Hey, how's it going?
I was wondering, could you use define and then like a line of code?
Yeah.
So you like a line of code to yes. You can say yes, 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 and then just keep giving that same line of code. Like,
yeah.
Would it recognize that as code?
Yeah. So the way that hash defines work is nearly like a text replacement. Yeah. So you can text replace one thing into another thing, and then you actually get like, I had some students a while back text replace yeet. Do you know yeet, right? Yeah. They text replace yeet to if, and then yeet with 3 E's to while, and then another yeet to curly bracket open, another yeet to curly bracket close. And so the code was just yeet, 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 and then some stuff, and then yeet, yeet, yeet. And I was just like, okay. I mean, so because what it does is it's going to grab the text and just replace. Yeah.
But how do you do like 2 things?
I'm not actually sure, because I don't think we can do things with spaces.
Yeah.
Once you have spaces, I have to look it up because I never use it for stuff like that. Yeah.
Keywords.
Not necessarily. Yeah. Maybe with brackets. You'd have to look up hash define and how it works, but I'm pretty sure if you put spaces, it'll treat them as different symbols. Yeah. Cool. No worries. Hey, how's it going?
This is really weird. See that?
Yeah.
I've declared the variable x twice, and I'm using the compiler GCC on Windows, right?
Yeah, GCC, that's the problem. GCC
Yeah.
will not tell you there's a problem there.
But there is a problem.
There is a problem.
Yeah.
You have 2 X's.
Yeah.
I don't know what GCC is doing there. See, I'm not even sure whether it's creating another variable,
Yeah.
or it's just linking you back to that variable,
Yeah, right.
or this X
Yeah.
is the X for inside here, and this X exists outside of it.
Wow, it's not giving me the...
So that's the scary thing, is
Yeah.
you can't even be sure how this code's going to work.
Exactly.
Yeah. So that's the risk with GCC.
Yeah.
As a compiler that, like professionals use, sometimes they break the rules on purpose and get away with it.
Yeah.
But I don't want us breaking the
Yeah,
rules because
exactly.
it's dangerous. Yeah.
Stylistic-wise, I should really use int or the x in this loop here.
Yeah. Or
Yeah.
what you've done there is get rid of the int and you're at modifying that
Yeah,
same X,
true.
and that's fine as well. Yeah.
Thanks.
Cool. No worries. Hey, how's it going?
I
Ooh, what are we
this
doing?
code to work since like yesterday's dice checker one,
Okay.
because he's telling me that. And also, I don't know why I can't open those 2 together. When I do that, the terminal just closes down.
So did you, when you type in gedit, did you put an and on the end? You may not. Yeah. So
don't know, I
one of the
can't
things,
find out.
just close this for now.
Okay.
Yep. And in here, in your terminal, yep.
Yeah.
Let's have a look at your gedit. Actually, let's just type it in again. So gedit. What's it called?
Dice checker 1 underscore checker. Yeah.
Dice checker 1.c. If we do this, you do the and
Yeah.
on the end, then that will keep this open while your gedit window's open.
Okay.
Yeah, so now you've got both of them, and you can keep using both of them. Okay, so you were having some compilation issues there,
Yeah.
were you? Okay, so one of the tricks with compilation, if you go back to the errors there,
I tried to do that, but I clicked like.
one of the tricks is
Yeah.
only look at the first error, because all the other errors could just be a consequence of the first one. So if we go up until
Here.
yeah,
Yeah.
error, close brackets, else. Okay, let's have a look. It didn't even tell us what line that was on. Oh, wait, undeclared identifier. You've used total on line 75, which hasn't been defined. Okay, so let's go there and have a look at line 75. So total is equal to die1 plus die2, and there's an int total there.
Well, I can just
Okay.
make it all one line, right?
No, it's fine. Like, what you've done there is fine.
Yeah.
This could be some weirdness happening with these curly brackets. So I can see a closed curly brackets there that might or might not be ending your program at that point. So what I would suggest is go through, look at all the open curly brackets and the closed curly brackets, and make sure that there's the int main and the open, and then the close for that one is at the very bottom. And then everything else that happens inside, indent it and say this is inside the main. Every time you open for an if, it closes, and every time you open for a while, it closes, and just sort of make sure all your brackets are open, close, open, close, open, close.
And while.
Yeah.
Close before an else.
Yeah, the if will close and then the else will be after it closes. So I think you may have just the wrong number of open closing brackets,
Okay.
and it might be closing the whole program there, which means none of this can run. That might be the compiler error you're getting. Yeah, so I would check that, yeah. I'm gonna have to keep going, sorry, come afterwards and we'll chat, yeah? Alrighty. Alrighty, let's get going again. Sorry, that was a longer break than I should have gone for. Can I have your attention, everybody, please? Thank you. Let's get rolling. Get it? Get it? Dice application, let's get rolling. No one left, that's good. Okay. Okay, everyone settle down, settle down. Let's keep going. So, I'm adding a new possible program here that is called a dice statistics, which is slightly different from the dice checker that we had before. I now would like a program that tells me, say I'm rolling 2 dice, it'll tell me, okay, what are the odds of rolling a particular number on those 2 dice? Or how many possible values can those 2 dice reach, and what are the ways that it can reach those values? And so the way I'm going to do that is I'm going to use looping and numbers with this to be able to build up 2 dice and their possible statistics. Whenever we have something like that where I say, okay, I want all the possible values of 2 dice and the chance it has of rolling any particular number, we can start thinking of this in that kind of problem-solving sense. What are the toys we have to play with? Which of our toys apply to this particular situation? So if I want all possible values of 2 dice, then I'm looking at, say, rolling 1 die and getting, so 1 through to 6. And for each of those values, 1 through to 6, I want to roll the other die and see what other values it could get. So you can see why this example comes directly after I showed you looping within a loop, because I think that that's going to be a reasonable solution to this. If I do a loop of 1 die, and then for each possible roll of that die, I loop the other die through all its possible rolls, I should be able to see all the possible rolls of 2 dice. So any of you who have done, like, sort of... Actually, is anyone doing any statistics at the moment? I don't think you do statistics in first year, but you may have done some in high school, where if I want to roll 2 dice, 2 6-sided dice, if I was to place them next to each other and count how many possible rolls there are, there's 36. 6 on one dice multiplied by 6 on the other dice gives me 36 possible rolls. We can do this with 2 loops in the same way we just did 2 loops to print out 100 stars. I could do 2 loops to print out 36 possibilities of dice. I think I've got that there in the slide. We're going to be looping through all the values of 1 die and adding them to all the values of the other die, and then see what we get. What I like to do sometimes with programs like this is I pick a simple part of it and I implement the simple part of it, make sure it's working before I start to try to add something more difficult to it. So I'm not worried yet about the other things of like picking a number, telling me the ways the dice can reach that, and my odds. Don't worry about that. First thing I want to do is just figure out, can I just see all the different ways that 2 dice can be rolled to get different values? So simple thing like this, I can grab the size of the dice from the user and I can store those in variables, and then I can loop through both dice and just output what the totals are. So don't worry too much about this code, it's here for your reference, but I'm going to actually do it with you now. So back across here, I'm going to close my loop demo because we don't need that anymore. And I'm going to start a new one. Gedit dice stats.c. And we'll put an and on the end there so I can go back and forth between these 2 windows. So I have a fresh file, nothing in it yet. Dice statistics. What's it going to do? This will show all possible rolls of 2 dice and report the odds of rolling a particular number. And it was written by me, 26th of the 2nd, 2020. All right. I'm going to set this up like any other program with all the basic things that I need to get going. So if I want to be able to read anything from the user or print anything to the terminal, I'm going to need the standard input-output library.h. We're going to talk about h files later. And then I'm going to need the main, which is the thing that every program needs to run. So int main void. So don't worry too much about what all this stuff means. I will, potentially next week, go through that main function and tell you what all that stuff means. I'm still deciding out whether that's going to go next week or the week after. This can have a return 0 at the end to say when it finishes. I don't know if anyone else has noticed, while you've been doing your lab exercises and stuff, that if you leave out the return 0, the program still finishes fine. So C actually has a thing where it defaults to return 0. So if you don't put the return 0 in, if it reaches that final closing bracket, it will actually do return 0. So I'm putting it in there for completeness, but it doesn't actually always have to be there. Okay. So the nice thing about this, and this is a good thing to remember, is this is the way to start most of your programs. Because now you have a complete program that definitely works. It's going to compile and it's going to run. It's not going to do anything because I haven't put any instructions in there. But at least I know it's complete before I start playing around with it. So I don't accidentally do something like this and forget to close my final curly brackets there, and then the compiler will have no idea what's going on because it won't know when the function finished. Okay. So in here, I am now going to take input from the user for the size of 2 dice and then show them all the possible ways we could roll the 2 dice. So if I have 2 integers, and you go die 1, actually it's not die 1 because it's not really the value of the die, it's how big it is. So die 1 size. I might initialize it to 0 just to be like, if we don't get any input, then we're not going to do anything with it, rather than having it floating around with no value. Die 2 size starts off at 0, and then I'm going to ask the user to type in the size of the 2 dice. So printf. Oops. First die, and I'm going to leave it there on that line so they can type it in directly after that. I'm going to scanf. Oops, I keep doing page up. It's right next to my arrow keys. Scanf into a number, and that's going to be die 1 size. I'm going to do the same thing for the second die, and I'm just going to get a little cheaty there. Copy that and paste it and change the things that I need in here. So the second die is going to be in here, die 2 size. Okay, so when I get to this point, I should know the size of the 2 dice. Question there, yeah. Oh, the question was, how come I don't have an and in front of die 1 size? Because I forgot. And when I compiled this, my compiler would probably just go, I have no idea what you're doing there, because that's not C. Yeah, so thank you for that. Again, I love the fact that I just want, every time I'm coding, I want 500 people watching me, because like I'm never going to make any mistakes like that. It's really good. But thank you for pointing that out. Okay, so this is going to scanf in those 2. So now, previously it wasn't going to, but now I'm actually going to get those values in those variables. So with those variables, I might actually just sort of explain what I'm doing here. Take input for both die sizes. Then here, loop through all possible roll outcomes and print. So what I want to do now is I want to loop through 1 die, and then for each roll of that die, I'm going to loop through the other die, and I'm going to print out what the total was for each of those. So if I know I'm going to loop through one of them, I know that I've got a loop, but I need to think about how I'm going to start this loop and how many times I'm going to run this loop. So, oops. I'm just going to put some white space at the bottom so I can put it in the middle of the projector for you. So if I know I'm going to loop a certain number of times, I'm probably going to do one of those loops that starts at 0 and goes up to a certain value. So I need a variable that's going to go through a certain number of times and hit a certain point. So it's going to start at 0. I'm not sure what exactly I should call this, but I know if I'm going to loop within loops, this is going to get messy. So I might actually even just go, I'm going to call it counter 1. So there's a counter for die 1, and there's going to be a counter for die 2 as well. So if I name them differently, I'm going to be able to remember what they are. So counter 1 is equal to 0. And I'm going to do this. So this you haven't seen yet. I have a slide for this. So I've done counter 1 plus plus. Let me just pause for this new syntax that I'm using. You don't really have to use this if you don't want to, but I use it a lot because we add 1 to numbers a lot, and this just makes things a little bit easier to type in. So die 1 is equal to die 1 plus 1, or die 2 plus plus. Both of these are going to end up the same thing afterwards. So putting plus plus after a variable just adds 1 to the variable. We call it incrementing. So we're going to see the idea of incrementing a lot. Incrementing means you just keep going up by 1. And it makes it sort of easier in our loops to always think of the fact that we have a case by which we stop in the loop, and then something in the loop that's probably going to increment something. Not all loops do that, right? The other one that just turned off occasionally doesn't have an incrementer. But these loops that go through and run multiple times very often will have this incrementer here. So I know that my counter 1 is going to start at 0, and then it's going to go to 1, to 2, to 3, to 4, etc., until it reaches a point where it stops. So we need to decide how this is going to stop. And we said, we're going to run this for every value that the first die could have. So I might actually want to modify this loop from the way we were doing it before. So previously when we were counting exactly how many times we'd done the loop. But if I want to loop through a die, then maybe I actually want to start the counter at 1. So I want to start the counter at 1, but I also want to run the loop for the maximum value. So previously, remember, like when I was running the loop the 10th time, the counter value was 9. So it didn't go up to 10 until after that loop had pretty much reached its finish. So what I might want to do this time is if I want to run the loop from 1 to 6, for example, for the die size from 1 through to 6, I do want the loop to run when it's 6. So maybe I want counter 1 to be, instead of less than the maximum value, the maximum value is actually die 1 size. Instead of doing less than this time, I might do less than or equal to. If I do less than or equal to, then I have this situation where this is going to run, the first time it's going to run, counter 1 will be equal to 1. The final time it runs, counter 1 will be equal to die 1 size. So if die 1 size happens to be 6, this thing's going to run 1, 2, 3, 4, 5, 6. So what I'm doing is I'm just shifting these little questions and things like this until I get exactly what I want. So if I was doing something that I just wanted to do the numbers between like 3 and 8 or something, I could start this at 3. So there's no particular reason why we had to start the last one at 0, but I started the last one at 0 because it was going to give us some really good information about how many times this thing had run. But if I want to run it 1 through to the maximum, I can do it this way. And I'm pretty sure that this thing now is going to print out the numbers 1 through to the maximum dice size. I can test this now to make sure that it's doing what I want it to do. So printf, and it's worth doing this while you're developing. Like while you're partway through, it's worth going through and going, okay, is this thing doing what I want to? If I know it's doing what I want to, I can then move on to the next bit and add to it. One of the worst things that we do, and we do it a lot out of habit by accident a lot of the time, is we write like 100 lines of code before we test any of it. And then when we run it, it just flat out doesn't work. And then we have to go, okay, which bit of it doesn't work? And then we're not sure which bit of it doesn't work because we've written so much already. Whereas if you write small amounts, test it, make sure it works, and then you add bits to it, test them, make sure it works, you get into this habit of going, I know which bits work, and I know which bits are sort of more volatile that I've just added, and those are the bits that I will check for when there are problems. Okay, so printf, Counter 1 is something, and we'll do counter 1 there. So now I could just check and make sure this thing's actually going through the dice. I'm pressing the up arrow for something I haven't compiled yet, so I have to type it in once at least. So DCC, I called it dice stats. I just tab completed that, make it easier. -O says which file I'm going to write to. I'm going to call it dice stats because it's a good name for it. It's okay if the name is the same. It's okay if the name is different. Just remember that the .c is the file that you're actually editing, and then the thing without the .c is the program you're creating. Okay, I'm going to do /dice stats. Run that. So size of the first die. Anyone want to pick what size the first die is? Did someone say 6? I thought I heard a 6. All right, standard die. Second die is not doing anything yet, so I'll just make that 6 as well. Okay, we're looping through. I should have put an end line on this. Counter 1 is 1, 2, 3, 4, 5, and 6. So my testing statement is a bit ugly, but it is confirming that I'm definitely going through the numbers 1 through 6. So I'm pretty happy with how I've constructed that loop. If I had changed this to less than, I might get 1 to 5. If I'd started this as 0, I would have gotten a 0, which I didn't need either. So I've constructed that in a way that is giving me the response that I want. Okay, so I'm rolling one of the dice. So one of the dice is going up 1 through to 6. But what I want to do now is I want to say, let's roll the other dice against this dice and get all of my sort of 36 possibilities. So I'm going to get rid of that one because I don't need that right now. I'm going to make another while loop. Oops. Counter, and I'm going to make a variable called counter2 equal to 1. I know that I'm rolling 2 dice, and so I know that the structure for this other one is going to be really similar. So I'm going to use a lot of the same things for this other while loop that goes inside this one. So this one is counter 2. So note that I've got 2 variables. One variable controls one loop, and the other variable controls the other loop. So counter 1 controls the first die, and counter 2 controls the second die. So counter 1 is compared against die 1 size, and counter 2 here that I've just created will be compared against die 2 size. And I'm going to make sure that inside its loop, counter 2 will be incrementing. So what I've got here going on with my looping is making sure that the first loop runs exactly the number of times for how many possible rolls there are in the first die. And the second loop, each time the first one runs, it runs exactly the number of times necessary for the second die. So where I am now, inside this counter 2 loop, I have exactly the die 1 size multiplied by the die 2 size number of times this is going to run. And it's going to have different values each time because say it's 6 and 6, this is going to run 6 times when die 1 is equal to 1, and then die 1 goes up to 2, and this will run another 6 times, die 1 goes to 3, this goes through 1, 2, 3, 4, 5, 6. So hopefully what I'm going to get out of this is if I put some code in here, it will be able to process all of the different values that the dice can create. So let's just do, oh no, I'm going to need a variable to add this stuff up. So int total is equal to, so the variables that are actually moving, so the die 1 size and the die 2 size are fixed. They're going to be like 6s or whatever. Previous time I typed in 6s, so they were 6s. But counter 1 and counter 2 are going to start from 1 and then count upwards. So those are the numbers that are changing. Those are the numbers that are actually representing the rolls of the dice. So I can have a new integer called total, and that's going to be equal to counter 1 plus counter 2. And remember that counter 1 and counter 2 are going to be changing their values every time this thing loops. So hopefully what I'm going to get here is this is going to go through all the possible values of counter 1 and counter 2 and add them up into each of these totals. So each time this total will be slightly different because counter 1 and counter 2 are changing. I'm going to print this out so that I can see what's happening. But also I think this was one of the goals, was to say, okay, this is the thing that we're looking for. So printf die 1. Oh, actually, I might just make this simpler. I'm just going to go this plus this equals this. So I know that they're going to be integers. I'm going to put an n line on the end because we're going to have multiple lines of this. And I'm going to say counter 1 plus counter 2 equals total. So I'm just reporting what code I wrote a second ago. So counter 1, counter 2. So remember, when I have multiple things in an if statement, I have multiple %ds in there. They just match up in order to the variables that I put after the commas. Total. Okay, counter 1, counter 2, and total. So hopefully what I'm going to get here when I run this is if I have 6-sided dice, it's going to run 36 times. It's going to print out 36 different lines, and each of those lines is going to show me one of the possible combinations of the two dice rolling. Let's see how this goes. I'm going to compile that. That was lucky. Usually when you write that much stuff, it doesn't just compile straight off. There's usually something you need to fix. But let's see how this runs. Dice stats, to keep it simple so we can understand what's going on, I'm just going to use 2 6-sided dice. So, first one is 6, second one is 6. All right. If I scroll up, maybe I should use smaller dice. Okay, 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, etc. Look at the pattern. The first die rolls a 1. That's the big loop on the outside. And then the second die looped 6 times inside that loop. Let's go back to the code, have a look. So this one ran once, and it set its die size. Well, it didn't even set its die size. Its die size was, sorry, not die size. Its counter was 1, and while its counter was 1, this one ran 6 times. So while the first one's counter was 1, second one ran 6 times. And then the loop finishes the first time, counter 1 goes up to 2, and counter 2 goes 1 through to 6. Counter 1 then goes up to 3, counter 2 goes back through 1 through to 6. Anyone who's played, Monopoly and stuff like that will be pretty familiar with these outcomes. 2 through to 12 are the numbers we expect to get out of dice. And there's lots of different combinations in here. If you've looked at dice in detail, you know that 7 is the most common thing you can roll, and we're getting a lot of 7s in there. And then it tails off, like in terms of the number of ways that we can roll the dice. But what we've got here is a nice thing, because this is showing us all the different ways that we can roll, all the different numbers that 2 dice can roll. And the other bonus is it didn't take us that many lines of code. So we've only taken 10 lines of code, well, a bit more than that. Actually, though, the loops are 11 lines of code there to be able to show us all the possibilities of these 2 dice. Okay, that's a good start. So we can see all the possibilities now, we can list them out, we know all the totals. If we wanted to, we could also look at how many times the dice were rolled there. So if I want to, I could have a total number of rolls and just add that up for every time the dice were rolled. Or if I want to be sneaky about it, I could take the 2 dice sizes and just multiply them together. And then I would know the total number of rolls. So let's have a look at the idea that one of the things that we were trying to do is say, what are the possibilities? What are the odds of rolling one particular number out of that lot? So we're going to check the totals of all our rolls and see if they match a particular target roll we're looking for and count how many times that happened. So we also have a target value now that we can put in there. So here's some code for that. And then we're going to loop through and check against that target value. So let's go back into the code. I apologize, I don't write the code exactly the same in the lectures as they are in the slides, because I don't really want to copy it out. I do it from the way I'm thinking about things as we're going. And as you've noticed, when someone gives me a suggestion, I try to include it in the code as well. So it won't be exactly the same, but it will do the same thing. I mean, it would be pretty close because I wrote both of them, but you know. Okay, so if we want to have a target value that we're trying to test how many ways we could roll that target value, we could ask the user for that. So in here, when we're asking the user things at the beginning, I can say, please enter, I'll write it the same way. Please type in the target value. There. Oops. And I will scan in the target value. Oops. %D. And I'll remember to put my ampersand here on the variable. Okay. So now we have a target value that the user's typed in. Hoping that that target value was something that the dice can actually roll, but we're not going to do that right now because you know now how to do things like validating input and stuff like that. So you can do it yourself if you want to. But for the moment, we're going to ask them for a value, and then what we're going to do is we're going to check this total against that target value. So the first thing that I might do is something that's just the easiest thing I could do here is I'm just only going to print out the combinations of the dice that actually match the target value. So what if I put an if statement in here? So the if statement has a question and an answer, and I've set up my brackets for that in advance, so I know that I'm not going to get confused with that. And I'm going to say if the total is the same as the target, only if the total is the same as the target do I want to print stuff out. So let's put this print statement in there instead. So I'm going to Control X that, make some space for it here, and Control V that. So that's just a cut and a paste. Line everything back up. I'm being a bit quick here. Normally I would actually put more comments in this. So what I will probably do before I put this up online is I'll put more comments in here about the things that I was doing. But while I'm coding live, I will probably do things reasonably quickly. Now what I'm going to get is I will only get printouts of the combinations. Instead of getting all of them like this, now I'm only going to get printouts of the combinations if they match the target value. So let's try compiling and running this again. Let's see what it does. I'm always like amazed that it compiles every time, but it's probably because I've prepared these so carefully. I think sometime in the near future, I will write some code for you that just throws up a lot of errors, and we'll go through what it's like to fix errors. I'll do a thing on debugging. Okay, so that's a compilation there, and then I will run it using dice stats. So size of the dice, I'm just going to keep them as 2 6-sided dice for now because I think it's easier for us to continue thinking about them because that's, you know, standard dice sizes. And then as a target value, anyone want to give me a number between 2 and 12? 8. Okay, I got a clear 8 from someone over there. 2 plus 6, 3 plus 5, 4 plus 4, 5 plus 3, and 6 plus 2. So we have now been given exactly the combinations of 2 dice that can add up to 8. So this is nice. We're actually getting close to being able to say, what was the chance of rolling an 8 on 2 dice? So you'll note here that we've got 2 plus 6 and 6 plus 2, right? So this isn't really programming here. This is a statistics thing. So this is us sort of saying that if the first die was 2 and the second die was 6, that's one way you can roll an 8. But if the first die was 6 and the second die was 2, we could also roll an 8 that way. So just depends on how deep you want to go into the maths and stuff. The trick that we're getting here is that there are 5 ways to roll 8 out of the 36 possible ways that you can roll 2 dice. So we're now getting to the point where we could potentially start looking at some statistics and getting them to line up. So we've got output the rolls that match the target. So we're getting close there. Now we can identify the rolls. And if we want the odds, all we need to do is compare the number of times we rolled the target value against the total number of rolls that we had. And then we can just do some maths, and we can do some division. We can just divide the number of rolls that matched again, by the number of rolls that didn't, and we'll get the percentage chance of that happening. So we can keep track of how many of these worked by making an integer and saying every time we saw a successful total, we add 1 to that integer, and then we'll be able to count up the number of times that we do those things. So we've got a set of integers here. We don't even need all of them. Actually, we're going to use them anyway. It'll just be fun. It's part of the looping. So what we're going to do now is we've got our loops, but what we're going to do is we're going to increment these numbers every time we do something. So we have a number of rolls and a number of successes, and we're going to increment the number of rolls every time we roll the pair of dice. So every time we generate a pair of values for the dice, that's going to be a roll. But then the number of successes is only going to go up if the total and the target value are the same. We could also do the number of rolls just by multiplying the size of the 2 dice together if we wanted to. But I'm just going to use a little looping code and do it that way anyway. Okay. So what we have is we could actually make these integers up here if we wanted to. Int number of rolls, and that starts off as 0, and int number of successes starts off at 0. Okay. So if we've got this, and they start off at 0, what we want to do is get some values for them eventually. So here inside the second loop, this is where all of the pairs of rolls are generated, because every time this one loops, it loops 6 times, and then this one loops 6 times inside that one, so that's going to be the 36 total. So this is where we combine the 2 numbers into a pair. So this is where we make a roll. So number of rolls plus plus here means that what we're going to get is this is the total number of times that we've made a roll on the dice at all. And then inside this if statement, here, this will only ever run if the total matches the target, because the if statement said, if the total is the same as the target, then we run this. So this piece of code only runs if the roll was exactly what we wanted when we asked for a particular number. So I can go in here and say the number of successes goes up by 1. So what I'm doing now is I've taken these 2 numbers that started at 0, and I'm just slowly accumulating values to them. So every time the loop runs, the number of rolls goes up by 1, and then it checks whether the total is the same as the target value, and if it is, the number of successes goes up by 1. So number of rolls is going to keep going upwards. Number of successes is only going to go upwards if the numbers match. So what we should get at the end of this is that the number of successes is less than the total number of rolls. What I'm going to do is I'm going to print that out here after the loops are finished so that we can just see whether this is working or not. So printf we rolled the target value a certain number of times out of this many total rolls. So the first thing was the target value, so that's target. The second one was the number of times we rolled it, which was num successes. I'm going to need a new line here. And the total number of rolls was num rolls. All right. I'm just going to do my multi-line thing like that, so the brackets open and close like that, so it's just easier to see. Okay, so now when we do this, we should get something that I think we're still printing out the successes. Yeah, so we're still printing it out. This should be accumulating the number of successes and the number of rolls. So it should be able to tell us how many rolls were made in total and how many of those matched our target number. Let's have a look at that. I'm going to compile it and run it. Okay, I'm going to continue with the 6-sided dice. And I might actually just continue with the 8 that someone said before, because it works fine. So it shows us the ways that we can roll 8, and it says we rolled 8 5 times out of 36 total rolls. Question there.
Why didn't you get the other 4 and 4? Usually. Like, if you got 2 and 6 and 6 and 2, why
Oh, the question was, why didn't we get another 4 and 4? Because we had a 2 plus 6 and a 6 plus 2. I think it's because there is only one 4 and 4.
But if the order matters, like the 2 and 6 and 6 and 2,
Yeah.
shouldn't there be 2?
Except when the second one rolls a 4 and the first one rolls a 4, that one's already been accounted for by the first one. Whereas with the 6 and 2s, when the second one rolls a 2, the first one rolls a different number. So it's actually a different pair. There is actually only one 4 and 4. If I remember, you're pushing me into statistics here, but I'm pretty sure that that is still the right number of them, I think. Does anyone here know statistics better than me? I'm pretty sure, yeah, the doubles. Also, I'm going to trust the code because I think it enumerated them all. Yeah. So the question was, should we have more than one 4 and 4 there? But I think we should only have one. I think. Okay. So what we've got here is we know that now that we can roll 8 5 times out of 36 possible rolls, which means I now am much closer to my goal, and my goal was to be able to say how many, what's the percentage chance of rolling an 8 out of 36? So let's go back. I've got some slides on this. So the percentage should be something as simple as the percentage is dividing the number of successes by the number of rolls. That'll get me a fraction. I'll multiply it by 100, and then I should get my percentage chance. Right? Right? Everyone knows that when I do stuff like that, that I've obviously done a trick question. So we'll see. Okay, so let's put that code in and see what happens. So int percentage is equal to, I think some people who have done their tute this week may have seen this question already, because I know we put in one of the tutes. Okay, so num successes over num rolls. So this is me just saying this is like standard statistics, right? Or like fractions. Like if I divide the number of times I was successful by the total number of times, I'll get the chance of being successful. So percentage of this, that'll get me a fraction. I'll multiply that whole fraction by 100 to get a percentage. And I should be able to print this out. Oops. Success chance is that percent. And the value that I put in there was the one I just made called percentage. All right, let's compile that and run it and see what it does. Hands up if you already know what it's going to do. Has anyone ever, like, you know when you're a kid and you go to those little shows in like Centennial Park and stuff like that, and they've got the bad guy who's like full pantomiming, and all the kids are going, he's behind you, and the heroes are like, no, he's not, what are you talking about? This is one of those situations. So anyone who can see that he's behind you now, I will explain it anyway, but let's have a look at the same example. 2 6-sided dice trying to roll an 8. So if it's 5 out of 36, I'm expecting it to be, what is that? About 15%, I think. I'm just like back of the head trying to calculate that. Oh, the success chance is 0%. Oh, he's behind you. Okay, let's try it with different values. Maybe there was something going on there. So we'll try it with different values. So 2 6-sided dice, target value 7. 7 happens more than 8. 7 happens 6 times out of 36, so that should be exactly 1/6, which is 16.66 repeating percentage, if I remember correctly. Success chance is 0%. It's reporting 0% again. Does anyone know why that's happening? I think a lot of people do know why that's happening. There's a few people who said it. That's all right. That's all right. That's all right. Let me tell you something about this. So num successes and num rolls are both integers. You may remember that I mentioned this when I showed you integers in the beginning, that if we divide an integer by another integer, it was not going to give us a fraction. It was going to give us back another integer. So because they were both integers, I got back another integer. And because dividing any number that's lower than another number together, as in the successes were always going to be lower than the number of rolls, that was going to give me a fraction. The integer simply drops everything that's below the nearest whole number. So I was going to get a 0 for all of those except for if it was 100%. So this division was always ending up a 0. There's a way around this. If either of these is a double, then our percentage would be a double. So if I change one of these to a double, there's a few different ways I could do this, right? I could go up here and I could say this. The num successes is now a floating point number instead of a whole number. Then this division will probably work because one of these was a double. So this here, instead of dividing two integers and ending up with 0, will divide two integers, end up with a fraction, multiply that by 100, and then I will get a value. The downside to this is the number of successes is not a fractional value. You can't get fractional successes with these things. So I don't really like turning this into a double. I think that's messy. So I'm going to turn that back into an integer, and I'll show you a funny trick. So if any of the two values in a division or a multiplication, or I think addition and subtraction as well, if any of those is a double, the outcome is a double. So all I need is one of these two to be a double. I'm going to do something really funny. Times 1.0. So what's going to happen just here in this calculation is that the number of rolls, if I multiply it by a floating point value, will become a floating point value. So this thing that I put in brackets here will get done first, and it will turn the number of rolls into a floating point number. So because now one of the numbers in the division is a floating point number, if I divide the two of them by each other, the total of that is going to be a floating point number. Do you have a question up there? Oh, the question was, I have defined percentage here. I've declared percentage here as an integer. Does this still become a double? Parts of this will be doubles, but once I say that double goes into that percentage, I'm going to lose any decimal points that were in there. So if I have, say, for example, the 1/6 is 16.66666, this would give me 0.1666 repeating, and this times 100 would give me 16.66666, but when I put it into this integer percentage, I'll lose the 0.666. But at least that'll get me ballpark close. If I want to, I could actually change the percentage to a double. In fact, that's probably a nicer thing to do here. I will change the percentage to a double, and I'll output the percentage as a double, which means this will be LF rather than %D. All right, let's compile. Oh, we've got more questions? Yes?
Yeah, I just wonder the amount of decimal points. Can you control that, or just?
The question was the amount of decimal points that we're displaying, can we control that? Yes, we can. So there's actually ways to do this LF here that can change the number of percentage points. I'll have to look it up because I know it's like there's stuff that you can type afterwards. Another question there.
If you leave it as an integer as a percentage and then it cuts off all the decimal points, does it round it?
Ah. So the question was, if I left percentage as an integer, we're not done yet, everyone, we're not done yet. If I leave the percentage as an integer, will it round it to the nearest or will it cut it off? It will do the integer thing. It'll ignore the percentage point, so it's going to cut them off. So it won't round up nicely. Okay, so we've got a couple of minutes left. Let's test this and see whether our percentage is printing out something nice. So I've got to recompile it. And I'll run it. So let's just go 2 6-sided dice again, and that 8 that we looked at before. Cool. Now we're getting a genuine percentage for these things. So there's a 13.8 repeater percentage chance of rolling an 8. If I do it again and the 7, there was a 16.667% chance. So I hope everyone's got a decent idea now about looping. Remember the basics though.